Today we're going to look at interpreting graphs of functions, and primarily we're going to be looking at the differences between linear and nonlinear functions, but we're going to have some specific focus on the characteristics of these functions, whether they be linear or nonlinear. So it's going to draw a lot from the prior knowledge that we gained through our study of linear functions in particular, and what we've just learned relating to nonlinear functions. So most of the questions you will see are quite involved and look somewhat similar to this. You can see that before we go into the illustration of the graph of y as a function of x, which we'll see in a moment, you can see that a lot of these questions are asking you to complete sentences based on that graph. Okay, so just be careful to read these questions carefully. In particular, there's some instructions. Khan Academy, for example, does does need you to follow some of these instructions. So when you're talking about the x-intercepts in sentence number 3, it is asking you to list those x-intercepts from least to greatest. This is a coding issue, of course, that if you don't do it from least to greatest, it will mark it incorrectly. So just be careful that you follow every instruction in these questions to the letter. So we've got 5 sentences that we need to answer. We'll look at them one at a time. So let's first of all take a look at the graph that we've been given. So here's the graph that we've been given. We can see that it is not a line. Our previous skill in particular looked at linear versus nonlinear functions. So the first thing we see that this is not a line, therefore it's a nonlinear function. There are some characteristics about it we can see. We also noted earlier on, just when I was at the beginning of the video, about x-intercepts. We know that the x-intercepts are where a function crosses the x-axis, and we can see that this function crosses over in 2 locations, so that's going to be a primary point as well. We notice that there is one y-intercept where it crosses the y-axis, and there's some other things that we might need to take into account as the highest point, for example, the maximum point, and so on. So let's take a look at what are the sentences that we need to fill. The first part we're being asked is the graph of a something function. Well, we click on the drop down here, we see nonlinear, linear, or constant. Now remember that a nonlinear function is a function that is not a line, such as the function we have below. A linear function is a straight line. A constant function is a type of linear function. A constant function is of course, a function that is neither increasing nor decreasing. It is usually a horizontal line, though a straight line, a vertical line could also be a constant function. But this one here is a nonlinear function. We just discussed that. The y-intercept of the graph is the function value y equals something. Well, we did mention that there was a y-intercept to this, and we can see that the y-intercept is, of course, the point where the function crosses over the y-axis, and we can see that is the origin. That is the point where y equals 0. That is quite a simple one to identify. The next ones here, and we're being asked specifically to order them from least to greatest. The x-intercepts of the graph are located at 2 points. This is, of course, a curve, and this function is a curve, and it is going over the x-intercept once at x equals 0, and it comes back down and crosses over the x-axis again at x equals 6. So 0 and 6 are our x-intercepts, the points where they're crossing the x-axis. So 0, x equals 0, and x equals 6. Now the next sentence here, the greatest value of y is y equals something, and it occurs when x equals a particular value. Now the greatest value of y is the maximum value of this function, and we can see here this function increases all the way until it hits y equals 9, and then it starts decreasing again. So y equals 9 is the greatest value of the function, and it occurs when x equals 3. We look down at the x-axis and we see that that point where 9 is the highest value of the function is occurring when x equals 3. So far so good. Okay, so now we're looking at a range of the function. We're specifically looking at the range from x between x equals 0 and x equals 6. Now, my scratch pad does not go down this far, but what we can see here is this is x equals 0 here. So we're not going to look at anything below x equals 0. So all of this section here of the function is out at this point. And if we look at x equals 6 is the high point that we were asked to look at. And so all of this part of the function is also out. So we're just looking at this part of the function, and I'll hide the part we're not looking at. We're just looking at this part of the function that is above the x-axis. Now that's important because what we're being asked to identify is the y values of the function. We're saying, well, all of these y values of this function, and we're being asked, are they less than 0, greater than 0, or equal to 0? In this case here, all of the y values between 0 and 6 on the x-axis, all of these y values are all positive. They're all greater than 0. Okay, so as you can see here, these questions, they're just asking you to identify the characteristics of the graphs of functions. So let's take a look at a couple more. Now, so interpreting a different type of graph of function. So in this case, again, read the question carefully. A doctor observes a graph that shows the electrical activity in volts of a heart of a patient over the period of time in seconds. Each local maximum of 0.004 volts corresponds to 1 heartbeat. The doctor needs to calculate the heart rate of the patient in beats per minute. What is the heart rate of the patient? So you can see here the local maximum of 0.004 is right here. This is the 0.004. So each one of these is a local maximum. So it's a maximum value of this function, and of course it's occurring many times because it's a heartbeat, of course. And the question is, and it's over a period of time in seconds. We'll take a look at the x-axis in a moment, which is of course the period of time, and it's asking what is the heart rate in beats per minute. Well, when we look at this here, we see, well, we've got seconds here. Okay, and we can see right now that for every second we're going. Well, we've got one heartbeat here. We're not quite hitting a second. 2, 3. By the time we get to 2 seconds, we've got 3 heartbeats. We got 3 more by the time we get to 4 seconds. We know there are 60 seconds in a minute, but we're getting 3 heartbeats for every 2 seconds. So 3 heartbeats for every 2 seconds, of course, is if we've got 3 heartbeats. So if we've got 3 heartbeats at every 2 seconds, we've got our v value here, right? Is 3 heartbeats. Well, that's not quite true, but we've got 3 heartbeats for 2 seconds. If we were to extend this out to 60 seconds, that's the equivalent of multiplying times 30. So what we need to do here is multiply 3 times 30, and that of course gives us 90 beats per minute. Okay. Okay, let's look at a couple more questions. Here's another one similar to the first question here. You can see the various different things we're being asked to answer here. The graph of y is a function of x. Here we can see we have a curve that's an exponential curve. We can see as x increases, as the x value increases, the y value decreases. See that? The x value, so the x value is increasing from a negative number all the way up, but as it increases, as the x value increases, the y value is getting constantly smaller. So as x increases, y decreases. All right, your 3 options there: increases, decreases, or stays constant. Constants would of course be a straight horizontal line. The rate of change for y as a function of x is not constant, and the reason is our options here are constant or not constant, and this ties into whether a function is linear or nonlinear. A constant rate of change is a slope, and the slope of a line, of course, is a a linear function. So if the rate of change is constant, that is a line and therefore a linear function. And if the rate of change is not constant, we can see here that we've got at the value 1 we've got 5, at the value 2 we've got 3, at the value 3 we've got 2. This is not a uniform rate of change. This is something that is different every time. So we have a rate of change that is not constant, and therefore because of that we have a nonlinear function. Okay, see some of the options you might be given here. Increasing function doesn't necessarily tie into that question at all, so they will try and trip you up. It is essential that you know all of the characteristics that we've been looking at so far. So keep on going. For all the values of x, the function value y is it greater than or equal to greater than? We've got, is it less than 0, is it greater than 0, or is it equal to 0? Well, we can see here the y values here. If we look up here, we see all the y values, they're all positive y values no matter where you look at it. And it seems that this particular function is going to go on forever, probably not quite hitting the x-axis at all, because of the type of function it is. So the y values are greater than 0 for all values of x. The y-intercept of the graph is given. It is, of course, the point where the graph crosses over the y-axis, and that is, you can see it right down here, is the point where y is equal to 8. And when x equals 1, the function value of y equals what? So, well, they want us to look at x equals 1, and we want us to find this, and it looks like it is at 5, and I'm quite satisfied it is exactly 5, though it's not necessarily 100% clear that that is true, but it looks like it may well be 5, and that's probably what they're looking for. Okay, we'll take a look at one more. Again, similar sort of question to the heartbeat question. In this case, we've got cycles of the moon observed from Earth during the first 60 days of a year. The percentage of the moon we see varies as a function of time. This, of course, is a real-life situation. A full moon corresponds to 100% visibility. We can see the full moon right there, full moon there, full moon there. And new moon corresponds to 0% visibility. There's your new moon here, new moon there, and there's also a new moon right there as well. We'll talk about that in a minute. Okay. The following sentences are based on the graphs of the function. The first new moon of the year was on day what? Well, let's be careful. The first new moon of the year, let's read this again, during the first 60 days of a year. Well, let's look at the graph. Here's the first 60 days of the year. Day 3, day 6, day 9, and so on up to day 60. Don't assume that this is the first new moon of the year. Quite the contrary. This is the last full moon, or the last new moon rather. This is the last new moon of the previous year. So be very careful that you're not choosing this one right here. The first new moon of the year does not occur until day 24, when we get the 0% right there afterwards. So just be careful of that. The first new moon of the year was on day 24. The second new moon of the year, well, now we can move on to day 51. It looks like roughly day 51 looks about right. There we go, it was on day 51. And finally, therefore, the period between two new moons is approximately how many days long? Well, that's an easy one. All we've got to do is take that 51, subtract 24, and we're going to find the period of time. Okay, so this, of course, is 27 days, and that would make a lot of sense. Of course, the word moon, the word month coming from the word moon. That is, the cycles of the moon are roughly a month long. Okay, so I'll leave you at that. The whole point is just analyze the graphs, take a look at the graphs, and think about them logically. And I think you shouldn't have much trouble with this.